touchscreen technology has become part of our everyday lives. We barely bat an eye while scrolling through Instagram or liking a friend's post on Facebook. But how does putting a finger on your phone's screen to perform these tasks actually work? There are three components that work together to create the magic of touchscreen capability: the touch sensor, the controller, and the software. The touch sensor can be one of three types: resistive, surface acoustic wave, or capacitive. Resistive and capacitive are the most common and are quite ingenious. In resistive systems, two metallic layers become connected, which causes a change in the electrical current, which registers as a touchscreen event that is sent to the computer controller for processing and can be used with either fingers or a stylus. In contrast, capacitive systems use a layer of capacitive material which changes the amount of electrostatic charge at the point where contact has been made and only work with fingers. In surface acoustic wave systems, sound waves are sent across the surface glass, but become absorbed when touched with a stylus. The controller determines the location of the stylus based on this absorption. The controller takes the information from the sensor and determines where exactly the touch has taken place. This information is then sent to the software, which reacts to the touch. This may seem like a long process, but it takes nanoseconds in real time. Examples of touchscreen technologies range from the smartphone that is very likely in your pocket, to bowling alley scoring systems, to digital cameras, to self-ordering kiosks at your local McDonald's. In recent years, they have grown more popular as self-checkout kiosks in libraries, grocery stores, and drug stores. Interactive whiteboards use a projection displayed onto the surface where the image can be manipulated using hands or a pen tool. E-book reading devices such as the Nook or Kindle, where the user touches the interactive screen to move through the pages, offer book lovers a way to cart around a multitude of items without the heft of physical tomes. Interesting facts about touch screens. E.A. Johnson is credited with creating the first touchscreen system circa 1965-67. His findings were published in 1968 regarding touchscreen technology and air traffic control. The Simon Personal Communicator, launched in 1992 by IBM, was the first touchscreen telephone. In addition to making telephone calls, it could send emails and faxes and had a calendar and clock, among other features. An engineer at ELO Touch Systems named Bill Caldwell developed the first curved glass touchscreen interface in 1977. This was the first time a device was ever said to have touchscreen technology. The first patent that featured touchscreen technology was granted to George S. Hurst, Jr., and William C. Caldwell on October 7, 1975. Every device that uses touchscreen technology has a touchscreen driver. This computer program is what turns the touch into a command within the computer. In the 1980s, General Motors introduced the first touchscreen technology into its vehicles, but due to high repair costs it was soon taken off the market. By 1973, CERN, European Organization for Nuclear Research, was using a touchscreen computer to control a particle accelerator. A touchscreen or touchscreen is the assembly of both an input, touch panel, and output, display, device. The touch panel is normally layered on the top of an electronic visual display of an electronic device. The display is often an LCD, AMOLED or OLED display. A user can give input or control the information processing system through simple or multi-touch gestures by touching the screen with a special stylus or one or more fingers. Some touch screens use ordinary or specially coated gloves to work, while others may only work using a special stylus or pen. The user can use the touch screen to react to what is displayed and, if the software allows, to control how it is displayed, for example, zooming to increase the text size. The touch screen enables the user to interact directly with what is displayed, rather than using a mouse, touchpad, or other such devices, other than a stylus, which is optional for most modern touch screens. Touch screens are common in devices such as smartphones, handheld game consoles, personal computers, electronic voting machines, automated teller machines and point-of-sale (POS) systems. They can also be attached to computers or, as terminals, to networks. They play a prominent role in the design of digital appliances such as personal digital assistants, PDAs, and some e-readers. Touch screens are also important in educational settings such as classrooms or on college campuses. The popularity of smartphones, tablets, and many types of information appliances is driving the demand and acceptance of common touch screens for portable and functional electronics. Touch screens are found in the medical field, heavy industry, automated teller machines, ATMs, and kiosks such as museum displays or room automation, where keyboard and mouse systems do not allow a suitably intuitive, rapid, or accurate interaction by the user with the display's content. Historically, the touch screen sensor and its accompanying controller-based firmware have been made available by a wide array of aftermarket system integrators, and not by display, chip, or motherboard manufacturers. Display manufacturers and chip manufacturers have acknowledged the trend toward acceptance of touch screens as a user interface component and have begun to integrate touch screens into the fundamental design of their products. The first finger-driven touch screen was developed by Eric Johnson, of the Royal Radar establishment located in Malvern, England, who described his work on capacitive touch screens in a short article published in 1965 and then more fully with photographs and diagrams in an article published in 1967. A resistive touch screen panel comprises several thin layers, the most important of which are two transparent electrically resistive layers facing each other with a thin gap between. The top layer, that which is touched, has a coating on the underside surface. Just beneath it is a similar resistive layer on top of its substrate. One layer has conductive connections along its sides, the other along top and bottom. A voltage is applied to one layer and sensed by the other. When an object, such as a fingertip or stylus tip, presses down onto the outer surface, the two layers touch to become connected at that point. The panel then behaves as a pair of voltage dividers, one axis at a time. By rapidly switching between each layer, the position of pressure on the screen can be detected. Resistive touch is used in restaurants, factories, and hospitals due to its high tolerance for liquids and contaminants. A major benefit of resistive touch technology is its low cost. Additionally, as only sufficient pressure is necessary for the touch to be sensed, they may be used with gloves on, or by using anything rigid as a finger substitute. Disadvantages include the need to press down, and a risk of damage by sharp objects. Resistive touch screens also suffer from poorer contrast, due to having additional reflections, i.e. glare, from the layers of material placed over the screen. This type of touch screen has been used by Nintendo in the DS family, the 3DS family, and the Wii U gamepad. Touch screens are found everywhere from our smartphones to self-serve kiosks at the airport. Given their many uses, it should come as no surprise that there are several touch monitor types. Each has its advantages and disadvantages and is suited to specific tasks. It's quite possible that you're not clear on exactly what a touch panel is, what the touch panel types are, or how they're applied in your daily life, beyond that of your smartphone. For that and more, we're here to help. A capacitive touch screen panel is coated with a material that stores electrical charges. When the display panel is touched, it draws a small amount of charge to the point of contact. Circuits located at each corner of the panel measure the charge and send the information to the controller for processing. Users must touch capacitive touch screen panels with a finger, unlike resistive and surface wave panels that can accommodate a finger or a stylus. Capacitive touch screens are not affected by outside elements and have high clarity. Infrared touch screens use a matrix of infrared beams, which are transmitted by light-emitting diodes, LEDs, with a phototransistor receiving end. The infrared beam is blocked when a finger or tool is used near the display. This interruption provides the device with input on the location of the finger or tool. A resistive touch screen panel is coated with a thin metallic electrically conductive and resistive layer that when touched causes a change in the electrical current, which is registered as a touch event and sent to the controller for processing. Resistive touchscreen panels are generally more affordable but offer only 75% clarity, and sharp objects can damage the layer. Resistive touchscreen panels are not affected by outside elements such as dust or water. Surface acoustic wave (SAW) technology uses ultrasonic waves that pass over the touchscreen panel. When the panel is touched, a portion of the wave is absorbed. The change in the ultrasonic wave registers the position of the touch event and sends this information to the controller for processing. Surface acoustic wave touchscreen panels are the most advanced of the three types, but outside elements can damage them. You interact with the touchscreen monitor constantly throughout your daily life. You will see them in cell phones, ATMs, kiosks, ticket vending machines, manufacturing plants, and more. All of these use touch panels to enable the user to interact with a computer or device without the use of a keyboard or mouse. But did you know there are several uniquely different types of touch screens? The 5 most common types of touch screen are: 5-wire resistive, surface capacitive touch, projected capacitive, PCAP, SAW, surface acoustic wave, and IR, infrared. We are often asked, how does a touch screen monitor work? A touch screen basically replaces the functionality of a keyboard and mouse. Below is a basic description of 5 types of touchscreen monitor technology. The advantages and disadvantages of type of touchscreen will help you decide which type touchscreen is most appropriate for your needs. Resistive touchscreen. 5-wire resistive touch is the most widely touch technology in use today. A resistive touchscreen monitor is composed of a glass panel and a film screen, each covered with a thin metallic layer, separated by a narrow gap. For instance, when a user touches the screen, the two metallic layers make contact, resulting in electrical flow. The point of contact is detected by this change in voltage. Advantages: can activate with virtually any object, finger, stylus, gloved hand, pen, etc. Has tactile feel. Lowest cost touch technology. Low power consumption. Resistant to surface contaminants and liquids, dust, oil, grease, moisture. Disadvantages: lower image clarity compared to other touch technologies. Outer polyester film is vulnerable to damage from scratching, poking, and sharp object. Surface capacitive touch screen. Surface capacitive touch screen is the second most popular type of touch screens on the market. In a surface capacitive touch screen monitor, a transparent electrode layer is placed on top of a glass panel. This is then covered by a protective cover. When an exposed finger touches the monitor screen, it reacts to the static electrical capacity of the human body. Consequently, some of the electrical charge transfers from the screen to the user. This decrease in capacitance is detected by sensors located at the 4 corners of the screen, allowing the controller to determine the touch point. Surface capacitive touch screens can only be activated by the touch of human skin or a stylus holding an electrical charge. Advantages: better image clarity than resistive touch. Durable screen. Excellent resistance to surface contaminants and liquids, dust, oil, grease, water droplets. High scratch resistance. Disadvantages: requires bare finger or capacitive stylus for activation. Sensitivity to ME/RFI. Projected capacitive touch screen. Projected capacitive, PCAP, is similar to surface capacitive, but it offers 2 primary advantages. First, in addition to a bare finger, it can also be activated with surgical gloves or thin cotton gloves. Secondly, PCAP enables multi-touch activation, simultaneous input from 2 or more fingers. A projected capacitive touch screen is composed of a sheet of glass with embedded transparent electrode films and an IC chip. This creates a 3-dimensional electrostatic field. Therefore, when a finger comes into contact with the screen, the ratios of the electrical currents change and the computer is able to detect the touch points. All our PCAP touch screens feature a 0-bezel enclosure. Advantages: excellent image clarity. More resistant to scratching than resistive. Resistant to surface contaminants and liquids, dust, oil, grease, moisture. Multi-touch, 2 or more touch points. Disadvantages. Sensitive to ME/RFI. Must be activated via exposed finger, or thin surgical or cotton gloves. SAW, surface acoustic wave, touch. SAW, surface acoustic wave, touch screen monitors utilize a series of piezoelectric transducers and receivers. These are positioned along the sides of the monitor's glass plate to create an invisible grid of ultrasonic waves on the surface. When the panel is touched, a portion of the wave is absorbed. This allows the receiving transducer to locate the touch point and send this data to the computer. SAW monitors can be activated by a finger, gloved hand, or soft-tip stylus. SAW monitors offer easy use and high visibility. Advantages. Excellent image clarity. Even better scratch resistance than surface or projected capacitive. High touch life. Disadvantages. Will not activate with hard items, pen, credit card, or fingernail. Water droplets remaining on the surface of the screen can cause false triggering. Solid contaminants on the screen can create non-touch areas until they are removed. IR, infrared, touch screen. IR, infrared, type touch screen monitors do not overlay the display with an additional screen or screen sandwich. Instead, infrared monitors use IR emitters and receivers to create an invisible grid of light beams across the screen. This ensures the best possible image quality. When an object interrupts the invisible infrared light beam, the sensors are able to locate the touch point. The X and Y coordinates are then sent to the controller. Advantages. Highest image clarity and light transmission of all touch technologies. Unlimited touch life. Impervious to surface scratches. Multi-touch, 2 or more touch points. Palm rejection capability. Disadvantages. Accidental activation may occur because the infrared beams are actually above the glass surface. Dust, oil, or grease buildup on screen or frame could impede light beam, causing malfunction. Buildup of snow and pooling of water, such as rain, can cause false triggering. May be sensitive to direct high ambient light interference. Higher cost. We hope you found these touchscreen basics useful. Thank you for watching this video.